Hello, this is 2.2 division of polynomial functions and factors and remainder theorem. Objectives is a long division, synthetic division, and vector and the remainder theorem. So division of the polynomial. As seen in section 2.1, the factoring is one of the ways that you can find the solution. But the factoring is essentially the underdoing of the multiplication. What else is undoing of multiplications? So this section will describe the two methods of the dividing polynomial and explain how the division can be helpful. Determine the factorization of the many polynomial functions. So the first method, we are using the long division. Similarly, in multiple way to the long division of the whole number, take a moment to consider the division of the whole numbers. Okay, so I want to divide 6,820 divided by 13. So 6,820 divided by 13. So 13 goes 68 5 times, about 65. And subtract, I got 32. And then 13 goes 32 2 times, which is 26. And subtract that as 6. And then 0 down. And then if I use 4, and then that's a 52. And then got a remainder. So the way that we answer, which is we just say, we put the remainder over 13. So we try to make the 6820 over 13 as improper fractions using the long division as a write out as 524 and 813, which is the same as 524 plus 8 over 13. So we try to keep the format of this one, okay? So what you do is we put the 524 as a quotient and then plus with the remainder, if you have, 0 means you don't have to put it, over and divisor. So we try to put the answers like this. All right, so let's look at the next page. So in the polynomial, so I'll show you how to do the example 1 and then you might have some idea for the second example, okay? So what I do is, okay, I'm using the long division, dividing it, 2x cubed plus 3x squared minus 6x plus 5 divided by x plus 2. So when we start dividing, so we need to divide it, right? Just like a whole number, right? We try to look for the one number goes that as the maximum number, right? So what I use is, I'm using the 2x cubed to divide by x always. So I do the division, which means I use the first term in dividend divide by the first term in divisor. Always, okay? So in here, I have a 2x cubed divided by x, which is 2x squared. So this, since we are doing the division, and this becomes a quotient. So you always get the quotient. So quotient place is always top of the line. So I put the 2x squared here. I try to match the degree, 2 here and 2 here, okay? And then once you're done, now we have to multiply. We do the multiplications. Just like we multiply the whole number too. So pull out your quotient, which is 2x squared. Okay, let me write down here. So what do you multiply? Your quotient times divisor. So I'm going to multiply 2x squared times of x plus 3, which is distributed. I got 2x cubed and plus 6x squared. So I'm going to put down as 2x cubed and then plus 6x squared. Then, of course, we have to subtract. Okay? So subtract means we're going to subtracting the product. This is actually the product because you multiply. So product, we're subtracting the product. So when you are subtracting, we are subtracting this. Okay? You're subtracting whole product. But which means actually you're subtracting this when you do this, and you're subtracting this. So you gotta change the sign. The best way to do is when you're subtracting a product means actually change the sign of the whole product. Change the signs of the product. And then once you do that, and then we just combine the terms. Okay, so once you're done, and then we just need to combine. So combine means this term has to be canceled because it's opposite, right? And then 3 minus 6 is a negative 3x squared. And then you got negative 6x plus 5. Oh, we just need the two terms, right, at a time, okay? Now, we're going to divide again. This time, I'm dividing negative 3x squared to the x, okay? So, negative 3x squared over x. So, I got negative 3x. So, I put down the negative 3x here. And then multiply negative 3x to the divisor x plus 3. And then negative 3x squared minus 9x. So I got negative 3x squared minus 9x. And then change the sign of the product. And then combine. Now I got 3x. Then down to 5. And then do it again. Now I got 3x. So use a 3x and divide by x, which is a 3. So plus 3 here. So multiply 3 times of x plus 3. We got 3x plus 9. So 3x plus 9. Subtract. Change the sign. Cancel negative 4. So we're done. So the way that we answer this question is, I'll just put down as 2x squared minus 3x plus 3. And plus negative 4 over x plus 3. Or you can just say minus 4 over x plus 3. That's perfect answers, okay? So that's what we do. Okay, so next one is, let's do it again. But the next problem, it's a degree of 3, but I don't see x squared. So we have to find the missing terms, okay? So we have to say 4x cubed. And then I have to use a zero coefficient x squared minus 7x plus 3. So if there's any missing terms, you just need to use as a 0 as a coefficient, because 0x squared is a 0 anyway. But yeah, that's how you do it. And then divide by 2x minus 1. So I do the division by 4x cubed divided by 2x, which is I got 2x squared. So I got 2x squared here. And then multiply, which is 2x squared times 2x minus 1. So I got 4x cubed minus 2x squared. So 4x cubed minus 2x squared. Okay, now we have to subtract, but we're just going to change the sign of the product. Okay, so change the sign. And then combine. Cancel. Now I got positive 2x squared. Drop the 7x. Divide again. So 2x squared divided by 2x. I got x. So plus x. And then multiply x times of 2x minus 1. I got 2x squared minus x. So I got 2x squared minus x. And then subtract. And now I got negative 6x. And drop the 3. And divide again. Negative 6x over 2x equal to negative 3. So minus 3. Minus 3 times 2x minus 1. Negative 6x plus 3. So negative x plus 3. And subtract. Oh, this time we got 0 remainder, right? That means, sorry. That means this is the solutions, okay? You don't have to write it because 0 remainder. Okay, so that's a possible way too. Okay, next problem. Now I have x cubed minus 8 minus 7x squared divided by x squared plus 1. So this is what we need for the long division. because the other two problems we can use the synthetic division, but which is I'm going to tell you what it is, okay? So this problem, we need a long division. So this is, but the problem is, this is degree of 3. Then I see square, but I don't see x, okay? But you have to write in the descending order. So which means you have to say x cubed minus 7x squared, but I don't see the x term, minus 8. And then divide by x squared plus 1. Okay, so division first, always. So x cubed over x squared, which is x. So put the x term here. So you just need to find the two terms for the quotients, okay? Multiply x times of x squared plus 1, distribute x cubed plus x. So x cubed plus x here. And then we subtract, change the sign. And then I got this cancel, dropped it, negative 7x squared. And then I got minus x. But this is actually the 3 terms, so divide just the 3 terms because x squared plus 0x plus 1, but you don't need to put the 0x, okay? And then we just subtract, right? Yeah. Change the sign of the product. Now divide again. Negative 7x squared divided by x squared. We go to negative 7. So negative 7x squared. Negative 7 times of x squared plus 1. I got negative 7x squared minus 7, okay? So negative 7x squared minus 7. Subtract. Change the sign. Cancel. You drop the negative x and minus 1. So we're done because this divisor is a degree of 2. And then the remainder degree of 1. So whenever the remainder is degree is less than the divisor, you cannot divide it. Okay? So the way of the answer is x minus 7 is a quotient. And then we pull the negative x minus 1 over x squared plus 1. So this is the way that you answer as a long division. Okay, so as the name implies, a long division is a fairly long process. So for that reason, we now discuss a second method. Division can be used for any polynomial that to be divided by the polynomial of the linear. It should be a linear, okay, not the quadratic. It's only the linear, so linear form. So one key idea beyond synthetic division is no variable needed to be written if we stay organized. This idea requires that the dividend be in descending order, important, and then 0 must be used for any missing terms, okay? So first of all, when I check the dividend, I got 2x cubed and 3x squared and the degree of 1 and degree of 0, right? So this is descending order. And then I don't see any of the missing term because starting from the 3, 2, 1, 0, right? So what you do is you just pulled out the coefficients, okay? So which is 2, 3, negative 6, and 5. Okay? So do not use a variable. And then once you've done that, we divide by, okay? Actually, you need to set the divisor equal to 0. And then this is the numbers that you use, okay? So instead of the 3 positive, we put negative 3 here. And then we only do the 2 things here in the synthetic. We add, multiply, okay? So first of all, there's nothing to add, so drop the 2. Now, I need you to multiply 2 and negative 3, multiply, which multiply 2 times negative 3 is negative 6. And then combine. You combine the 3 and negative 6, which is negative 3. Now, I need you to multiply negative 3 to negative 3, which is a 9. And then combine negative 6 and 9, which is a 3. And then multiply again, negative 3 and 3, which is, you multiply negative 3 and 3, and then it's going to be negative 9, and combine 5 and minus 9, which is negative 4. So that's it. So we do the only the two operations. So we add, we multiply. So these are the second row is all product. And this is actually the sums. Okay? And then the last number is actually the remainder. So last number remainder come out as a 0, which means the x plus 3 that we use here is factor. But since it doesn't come out as 0 as a remainder, so x plus 3 is not a factor so this time, okay? Then I want to show you how to write as the answer like the long division, okay? So good thing is, since we divide by linear, which is x plus 3, so this was actually the x cubed, right? And then divide by linear x, this becomes a 1 less than the whatever degree of 3, okay? So you always lower the 1 degree from the previous, okay? So this is going to be 2x cubed minus 3x and plus 3. And then, which means you have to write as 2x squared minus 3x plus 3 and plus of negative 4 is a remainder and then x plus 3. So this is how you write it. So if you use a synthetic, you're skipping all the steps as what we do here. We are actually just skipping all the steps. Okay, you just have an answer and the remainder. That's all. All right. Okay, let's go to the next page. So I'm using the synthetic to see. Okay. So in this synthetic, okay, so 7x cubed minus, so this is actually the 7x cubed minus plus 0x squared because I don't see x squared, right? Minus 7x plus 9. So pull out the 1, 0, negative 7, and 9 and divide by. But since the x minus 2 set equal to 0, add 2 both sides, x equal to 2. So we are using 2 now. You gotta be careful. And drop the 1. 2 times 1 is 2, adding it 2. 2 times 2 is a 4, which is negative 3. 2 times negative 3 is negative 6, and the remainder is a 3. So which means, since this is the x cubed, and this is x squared, plus 2x minus 3 plus 3 over x minus 2. That's all. See? You don't have to rewrite it. That's the answers. So this is your answer. Okay, next one. This means what? X cubed minus plus 0x squared plus, I don't see x term, but I see the constant, okay? So I got 1, 0, 0, negative 27, and divide by x minus 3 equal to 0, so for x is a 3. So put 3 here. Drop 1, 1 times 3, 3, added 3. 3 times 3, 9, 9. 9 times 3, 27. But this is a remainder, it's a 0. So good thing is, since it's an x cubed, which is this is x squared, plus 3x plus 9. That's all. Which is you can write that 3x plus 2 plus 9, okay? So that's the factors. You don't have to put the 1x squared, okay? Now divide. The x cubed minus 2x squared plus x to 4 minus 7 and divide by x plus 1. So first of all, we have to write the dividend in descending order, okay? So I need to put the highest power, and then second highest, and then I don't, and then 2x squared. But I don't see the x term, right? So this is it. So when you have a degree of 4, you're expecting the 5 terms, okay? Because starting from the 4, 3, 2, 1, and 0, okay? So now pull out the coefficients. So coefficients 1 from the x to 4, 1 from the x cubed, negative 2, 0, negative 7, and divide by negative 1, not 1, okay? And drop 1, multiply 1 times negative 1, negative 1, 0, 0 times negative 1, 0, negative 2 times negative 1 is positive 2, 2, 2 times negative 1 is negative 2, which is a negative 9. So this is actually 4, which means this is x cubed, right? So plus 0x squared minus 2x plus 2 plus of x plus 1, right? So if you want to write nicely, you got x cubed. You don't have to put the 0x squared minus 2x plus 2. And then you can write the negative 9 over. You can do that too. So that's the final answer. So plus minus 9 or just a negative 9. That's fine too. Okay, so this is synthetic. So hopefully you understand what I'm doing, okay? All right, now the factor and the remainder theorem. So in order to find the numbers, the linear is a factor, so a not factor is about to the remainder. So if the remainder come out as a 0, and then we call that's a linear factor, and then the number that we divided in synthetic, we call the zeros. If not, we can do this, okay? All right, but first of all, the remainder theorem means you just plug the number, whatever output, and that will call the remainder, okay? So first thing is directly, I just gotta plug it in. So the example, so f of x, which is f of 1, I'm plugging in 1 index place. And then I got 2 minus 7 plus 12. Okay. And then I will get as the it's a 0, right? Isn't it? It's 0, right? That means we can call the 1 is a 0. Okay. Yeah, so that's what we call that as the 0 here, okay? Alrighty, so in here, so I need you, also you can use the synthetic division too. So there's no missing term, so you just pulled out the coefficient 2, -7, and 12, and divide by 1. This one you can just use 1, okay? So when the 0 is a 1 means the factor is x minus 1, okay? So that's how you related this one to the 1. So drop the 2 minus 5, -5, -5, -12, multiply -12. Do you see the 0, right? Yeah. So these are the zeros, okay? So we did not introduce the remainder theorem simply as a second method for the evaluating polynomial functions. We now discuss the factor theorem, which is together with the remainder theorem will allow to use division to factor polynomial. So which means when you plug it in, you should get a 0 for the number. So it is a power. Okay, so hold a second. It is a power of the 2 theorem combined that gives us our most useful tools for the factoring polynomial. Okay, so let's look it up. So if during the process of the synthetic division you determine the remainder is a 0, we have find the factor. If you're not, well, that's not a factor. So but the thing is we want to make sure these are factors, okay? So I pulled out 2, -7, and 12. And then x minus 3, that's why I use. So drop 2 times 3 is 6. Combine -1, -1 times 3, -3, -10. And then -30, which is -18, right? So which is not equal to 0. So nope. Which means 3 is not a 0. Do it again. 2, -7, and 12 divided by 1. Drop 2, multiply 2 again, -5, -5, -12, -12 equal to 0. Yes, because that's equal to 0. So yes, yes. X minus 1 is a factor, and then 1 is also the 0. Is it the x minus also factor of the f of x equal to 6x to 4 minus 5x cubed minus 23x squared minus 7x minus plus 5? Okay, so pull out is 6, -5, -23, -7, and 5. And divide by 1. 6, 6, 1, 1, -22, -22, -29, -29, -24. Which is not equal to 0. So nope. Which means 1 is not a 0 of the polynomial. Okay, alrighty, let's look it up to the next page. So we finished this section by section by factoring techniques involving synthetic division using the factor remainder theorem. So record that the x minus 1 was a factors of that because you got the remainder, right? So which was 2, -7, -7, and 12 divided by 1. So drop 2, 2, -5, -5, -12, -12 equal to 0, okay, because of 0. And then this is actually the 0, and this is a factors, right? So complete f of x equal to 3x cubed plus 14x squared minus 7x minus 10 given factors. So which means x plus 5 is a factor, so you can use x plus 5 divided by 2, that f of x. You can see the remainder, but I'm using the synthetic, okay? So there's a 3, 14, -7, and -10. And then I divide by -5. So I know it's going to be a 0 already because it's a factor, okay? 3, -15, -1, 5, -2, 10. Yes, see? -10 plus 10 is a 0, right? Okay, so now, which means this becomes a 3x squared minus x minus 2. So now this is now 3x squared minus x minus 2 is a quadratic, but quadratics are always solvable, okay? Since it's a solvable, it could be a factorable, it could be the quadratic formula, whatever you want. But I think it's a factorable, so 3x of x. I need a plus 2 here and -1 here. So the other two solution is 3x plus 2 equal to 0. X minus 1 equal to 0. So subtract 2 both sides, which is, yeah, let's find the 0 first, okay? So 3x equal to -2, which is x equal to -2 third. That's another 0. This is 1, 0. And then add 1 both sides, x equal to 1. So we got 3, 0 for the cubes, okay? Now, it says a completely factors, okay? So f of x now becomes, but that's 0 form, which is you got first factor, second factor, and then third factor. That's all. So this is a completely factor form. All right, next page. Complete the factor f of x equal to 6x to 4 minus 5x cubed minus 23x squared minus 7x plus 5 given by x plus 1 and x equal to 5 over 2. So since we have a 2, 0, hold on a second. What's going on here? Sorry about that. I'm missing. Okay, let's go back. What happened here? What happened here? What did I do? Okay, all right, I'm back. Sorry about that. So first of all, I'm using -1 as a 0, and then I'm using the 5 over 2 as a 0, okay? So you can use either one, okay? So I pulled out the 6, -5, -23, -7, and 5, okay? And divide by. So drop the 6, -6, -11, 11, -12, positive 12, which is a 5, and -5, and 0. So I know it's a 0, okay? And then I'm doing it again with a 5 over 2. I know it's going to be a 0, okay? Oh, no, this is 0, but I know this is going to be a 0. Talk about this. This is already the 0. Sorry about that. Okay, so drop the 6. And then 5 over 2 times 6 is a 3. 2 go 3, 15, which is a 4. And then 2 goes to -10. Oh, positive 10. What am I doing? Then -2. Cancel, -5 equal to 0, you see? So we got this 2, 0. Now what I do is 6x squared plus 4x minus 2 equal to 0. Because this was x to 4. This becomes an x cubed, and this becomes an x squared. Okay? And then what you do is we try to get that as a factor form. So isn't it factorable? Okay. So so first of all, I'm gonna pull out the GCF 2, okay? So 3x squared plus 2x minus 1. So which means yes, it's a factorable, isn't it? So 3x and x, but I need the plus 1 here, -1 here as a 2x, okay? So complete factors as f of x. Now what are the factors? X plus 1, x minus 5 over 2, number factor, 3x plus 1 and x plus 1. So you just write them out, okay? So you got 2 times of 3x minus 1 times x plus 1 times x plus 1 times x minus 5 over 2. Okay, so now you got 2 times 3x minus 1, but this is the same, isn't it? X plus 1, right? So I mark a square instead. Okay, I think that's all. But also, you can put the 2 inside of, you can multiply 2 inside of here to here. And then you also can get 3x minus 1 times x plus 1 square. And then you can say 2x minus 5 too. So that should be a fine, okay? All right, that's all. All right, so thank you for listening.